Hi, my name is Walker Daniel, and today I'll be presenting my Lab 6 magnetic molasses. Introduction. The purpose of this lab was to observe the slowing effects caused by a magnet falling through a tinfoil tunnel. Then we were supposed to create a computational model of the observation created in GlowScript. This is a little preview of the data and the results. The magnetic bar fell slower through the foil tube because of the upwards magnetic drag. The system was the magnet and the foil tube, and the surroundings was everything else. Here are some fundamental concepts necessary for the lab. The first one is Faraday's law's equation. Second one is the magnetic field model. As seen here, this is the dipole one. Newton's second law, F equals ma, and finally Newton's third law, for every action there's equal and opposite reaction. So for our experiment, first we had to drop a bar magnet down a tinfoil tube. Then we measured the time the magnet took to reach the bottom, and then finally we repeated this four more times in order to get the average. And this is what our results look like. So here were some initial measurements. First, that the magnet's mass was 0.24 kilograms, the tube's length was 0.47 meters, inner radius was 0.025 meters, and then the width was 0.011 meters. And then for our trials are here. For the first one is 1.2, 1.1, 1.19, 1.22, 1.2, and 1.17, which gave us an average of about 1.196 seconds. And this is my code. You can see here, this is where we entered some of our base data. This visualized um, the the second part visualized the tube and the magnet, and then finally our calculations. And this is what my code outputted. I'm sorry for the blurry images, but of course we have this graph here, and then a little depiction of what's really going on inside the tube uh, magnetically. Of course, were some errors were not perfect after all. There could have been some accidental force added when dropping the magnet. There could be human error with timing, rounding errors, or inaccurate measurements. Some future questions. What if the resistivity of the conductor were reduced as close as possible to zero, and how would the dynamics of the falling magnet change? Well, the magnet would lose all velocity and stop inside the tube. Um, because it would start approaching infinity. And then if the second question is, what if holes or slots were cut into the tube? How would this affect the ring currents in your model? Well, the magnet will fall through faster because there's no longer a close circuit. And that's all I have. Thank you so much.